Hello, welcome back. Here we are to solve some additional questions on derivative. For today, the first question, as you see here, it says f of x is equal to x times absolute value of x. And then we are asked to find the derivative. Actually, the question says which one of the following is true. And it's talking, as you see, each choice about the derivative of the function. The function f of x is equal to x times absolute value of x. This is the same as either x squared or negative x squared. The outcome of x absolute value of x means it is either x squared when x is greater or equal to 0, and it's going to be negative x squared when x is 0. How do I get this result? Remember the definition of absolute value. Absolute value of x means it is either x or negative x. When x is greater or equal to 0, it will be positive x directly will be extracted. But if the x is less than 0, originally if this x is a negative number, yeah, that means when we extract, we have to put negative in front. So that x times x is going to be x squared. If it is negative x taken, negative x times x is going to be negative x squared. So we have two possible outcomes. These are the possibilities. Now let us see the derivative of this function. The derivative of this function means we have to see separately. The derivative of x squared will be 2x, and the derivative of negative x squared will be negative x. 2x works for x greater or equal to 0, and negative 2x works for x less than 0. But what about the derivative of the function just exactly at 0? That means the derivative of the function, like the derivative from the right side of the 0 will be 2 times 0 will be considered, and from the left side of the 0 will be negative 2 times 0. But 2 times 0 and negative 2 times 0, they will give us the same result. That means the derivative of the function at 0 will be just 0 in both, either to the right side, because remember the rule, normally derivatives, the derivative of a function at a point means, for example, f derivative at 0 means it is the same as the limit of f of x minus f of 0 the whole over x minus 0 as x approaching 0. This limit should exist. This limit, it has to exist. So how do we know the existence of this limit? The limit of this f of x minus f of 0 over x minus 0 as x approaching 0 from the right, it must be equal to the limit of the function f of x minus f of 0 over x minus 0 when x goes to 0 from the left. Right hand limit, this is, we call it right hand limit. This one we call it left hand limit. So that the right hand and the left hand limit of this limit exist, I mean equal, means we can say the derivative exists at that point. So when we say 0 from the right, we are going to take the first function, because 0 from the right means it will be considered for the first function 2x. I mean x squared will be taken. So when you take x squared here in place, it's going to be x squared, f of 0 will be just 0 and 0 also. So x squared over x will be, x left. But as x approaching 0 means you need to insert. The outcome will be 0. But for the left side, you will take the negative x squared. Negative x squared over x will be negative x remain. But when you insert 0, negative of 0 means just 0. So they are equal. But without this longer process, just you can see here, the derivative of the function will be either 2x or negative 2x. So when we say f derivative at 0, okay, f derivative at 0, from the right side, it's going to be 2 times 0. From the left side, negative 2 times 0. But 2 times 0 and negative 2 times 0 are the same. So the result will be the derivative of the function at 0 exists, which is just 0. So we can say, generally, f derivative of x is the same as 2 times absolute value of x. For x, an element of real number. For every limit, this function is differentiable at all real number, at any x, which is an element of real number. So that the answer is going to be B. Let's go to the next question. The second question here, it's saying f of x is equal, I mean g of x is equal to, here it is, f of x plus 1 plus 2 the whole square. This is the function originally. But there are some other given conditions as you see here. F of 1, negative 1, and f derivative at 1, negative, f derivative at 1, it's 1 given. So what is asked? We are asked to find g derivative at 0. Normally, this question has to be corrected. The question has to be g derivative at 0. This is what we are looking for. Okay, it says g derivative at x, but not. It must be g derivative at 0. So first of all, let us derive the function, and then we are going to insert 0. So g of x is equal to big bracket f of 2x plus 1, then plus 2 the whole square. This is a function. So we have to derive g derivative of x according to exponential rule, like power rule, like x the power of n derivative means, it's n times x the power of n minus 1. So I'm going to apply that rule here first, and then by chain rule the inner function will be derived. So this 2 exponent will come as a quotient, and it's going to be 2 times f of 2x plus 1 plus 2 remain as it is, times I will continue derivating now the inner function. What is the inner function? This thing plus 2. Plus 2 derivative is 0, so we can ignore. Simply let us focus here. This function also, it's a composition of 2. What and what? One, the function itself, f, and the other one is a linear function. So when you derive the function, it's going to be f derivative of 2x plus 1 times the inner derivative will be 2. So this is all the derivative of the function, but it's times, remember. The whole thing here, the yellow what you see, times f derivative of. By chain rule, what did I do? I derivate the f, here it is. Then times the inner 2x plus 1 also will be derived. That's 2. But the 2 plus 2, since it's constant, so we can ignore it. Now let us insert 0. G derivative at 0 means, by the way, these 2 and these 2 will be multiplied. It's going to be 4. I can write 4 here. And then when you insert here, what left? F of 1 remain plus 2 times f derivative. Again, when you insert 0 here, it's going to be just 1 remains. Now let us insert what we have. So 4 in big bracket, f of 1, it's given to you negative 1. So negative 1 plus 2, then times f derivative at 1 is 1. So negative 1 plus 2 will be just 1, and 1 times 4, 4, and 4 times 4, if finally the answer will be 4, which is found at A. Okay, let's proceed to the next one. The next question again, the function is given to you as you see, f of x is equal to 2 plus absolute value of x minus 3. And what the value of the derivative of the function at 3? That means we are looking for f derivative at 3. First of all, let's derive the function. Before that, let us remove the absolute value. F of x is equal to, what does it say? 2 plus absolute value of x minus 3. This is the same as 2 plus x minus 3 as it is, or 2 minus x minus 3. Because the absolute value of x minus 3 will be extracted as x minus 3 as it is, or negative of it. When x minus 3 greater or equal to 0, and when x minus 3 is less than 0. We do have two possible outcomes. So when you complete this one, it will be written as f of x is equal to x minus 1, because when you complete this one, 2 plus x minus 3 means x minus 1, because 2 minus 3 will be negative 1. And here we can shift the 3 to the other side, the negative 3. So when x greater or equal to 3, the function will be guided by x minus 1. And when x is less than 3, we can shift this one here also the same. And here the negative will be distributed. So finally, this will be the answer. That means in another way, in a number line, if negative 3 is somewhere around here, the function will be guided by x minus 1 for all values of x greater or equal to negative 3. I mean positive 3. Below 3, the function will be guided by 5 minus x. But what are we looking for here? We are trying to find f derivative at 3. So first, let's derive the function. The derivative of the function means it's 1 or negative 1. We'll derive the above. X minus 1 derivative will be 1, and 5 minus x derivative will be negative 1 when x greater or equal to 3 and when x less than 3. Now, as you see here, the derivative of the function for all x greater or equal to 3, it's 1. It's a constant. And for all x less than 3, it's negative 1. So the derivative of the function at 3 doesn't exist. At 3 doesn't exist. Because the derivative from the right side, it's always 1. From the right side of the 3. But the derivative of this function to the left side of 3 will be negative 1. So 1 and negative 1, they are not the same. right hand and left hand limit will not be the same. You can check like that of the first question. So they are not equal, so the derivative doesn't exist. It's going to be D. Let's continue. Here we have x squared plus xy is equal to 10. And then we are asked dy by dx when x is equal to 2. We need to find dy by dx when x is equal to 2. First of all, let's make the y alone. So shift the x to the other side. xy is equal to 10 minus x squared. Then divide by x both sides. So y will be 10 minus x squared over x. So what are we looking for? Dy by dx. We are going to derive both sides with respect to x. So this one is a quotient function. So I have to apply quotient formula, like quotient rule. The upper derivative will be negative 2x times the denominator is x. When you multiply, it will be negative 2x squared minus the lower derivative is 1. 1 times the upper one will be 10 minus x squared. The whole over the denominator square. The denominator is x. When you square it, it will be x squared. So it will be x squared. Here, how I do, you need to go back and check quotient formula. The process, the upper one is 10 minus x squared. When derivative negative 2x times x will be negative 2x squared. I wrote it, as you see here, minus the lower derivative is just 1. 1 times the upper as it is, here it is. So when you condense it, dy by dx will be written in the form negative negative will be plus. So negative 2x squared plus x squared will be negative x squared minus 10 over x squared remain. But we are not asked this result. We are asked when we insert 2. So dy by dx when x is equal to 2 means insert 2 in place of x. So 2 squared will be 4. So it's going to be negative 4 minus 10 over 4. This is going to be negative 14 over 4. We can simplify. Negative 7 over 2 will be the answer, which is found at A. So hopefully the simplification and the final answer here will be easier. The only problem is how to derive. This is negative 14 over 2, the same as negative 7 over 2. I mean 4. This is over 4. Yeah, this is it. Let's go to the next question. The next one here, it says f of x is equal to k times ln of x plus e the power of sine x. And f second derivative at pi is given to you negative 1. It's not at x actually. It must be f second derivative at pi is equal to negative 1. This is pi, not x. You can correct it. Then what's the value of k? So first of all, obviously we have to derive twice the given function. So the derivative of x will be, first k is constant, so k times ln x. So ln x derivative is 1 over x. So 1 over x times k will be k over x. We are trying to find the derivative, the first derivative. Plus, because it's sum, and e the power of sine x derivative is itself, but times by chain rule the exponent derivative. The exponent derivative is cos x. So I can write cosine x times e the power of sine x. This is the first derivative. What did I do? E the power of the whole thing derivative will be itself as it is, but multiply with the derivative of the exponent by chain rule. The exponent sine x derivative will be cos x, so I wrote it in that form. Now let us continue for the second derivative. But don't forget here the derivative of k over x. 1 over x derivative will be 0. It is the same as negative 1 over x squared. So the k constant. So when you are talking about now second derivative of x, it's going to be negative k over x squared. Because the k constant, it comes as it is. Because we multiply finally. But 1 over x derivative is, as I said here, negative 1 over x squared. Then plus, I have to apply chain rule here. There are two functions here. The first function cos and the second one e. So the cosine derivative, chain rule, product rule. What does the product rule says? F times g means f derivative g plus fg derivative. So our f is cos, so derivative is negative cos, negative sine x. So I can write here negative sine x times e the power of sine x plus cosine as it is, but e the power of sine x derivative itself times the exponent derivative, which is cos x. Cos x will multiply with cos x, so it's going to be cos square of x times e the power of sine x. This thing you need to take care systematically. What I did, you have to be clear here. Cosine derivative first, it's negative sine x times e the power of x, because product, I'm done, the first part. And when I go to the next part, what did I do? Cosine as it is will come, but e the power of the derivative itself times the exponent derivative by chain rule, which is cosine. Cos of cos times cos will be cos square x. Now we are asked to find f second derivative at pi is equal to -1. So what's the value of k that is? So it's going to be negative k over pi square. I can write it the next page. Let's go to the next page and write it. So what do we have? F second derivative of x is equal to negative k over x square minus sine x e the power of sine x plus cos square of x times e the power of sine x. We were here. And now f second derivative at pi means I'm going to substitute pi. So negative k over pi square in place of every x. But sine pi means 0. You know, sine pi is the same as 0 because pi means 180 degrees. So I can ignore everything here because sine pi 0 means 0 times whatever will be 0. So I'm going to go to the next part. And cosine pi is equal to -1, but it's a square. So I can change the color. Cosine pi it's -1, but when you square it, it will be +1. And sine pi, I said again 0, but e the power of 0 means 1. So 1 times 1 will be just 1 plus 1 is equal to what? -1. Because we are given f second derivative at pi means it says -1. It's given to us already. So we are looking for the k value. So let us do this equation. So shift the 1 to the other side. Negative k over pi square is equal to -2. Then the pi square will come. You can ignore the negative both sides. Then by crisscross multiplication, k value will be 2 pi square. So here let me write it once again. Negative of k over pi square is equal to -2. So finally the answer will be 2 pi square, which is found at A. Here it is. One last question. The last question here, it says f of x is equal to 1 over x. By the way, 1 over x means it is the same as x to the power of -1. So what's the derivative? Because we are asked n's derivative. N's derivative means just derive it repeatedly and see the pattern. How does it look? And then state a formula for it. So f derivative of x, you can start from here because exponent form will be beta power form. So -1 will come here as a coefficient. So negative x to the power of -2 because it will reduce by 1. -1 will make according to the exponent. Like x to the power of n, when you derive it, the n will come as a quotient, then x to the power of n minus 1. You are going to -1. So it was already -1. So when you make -1, it's going to be -2, the exponent. Okay, continue. This, by the way, this is the same as -1 over x squared. What about the second derivative? Again, derive this one beta. When you derive it, it will be 2x to the power of -3 to reduce by 1. This is the same as 2 over x cubed. What about the third derivative, of x? Again, derive this one beta. It will be -6 x to the power of -4, which is -6 over x to the power of 4. What about the fourth one? Let's check. Again, derive this one. It's going to be 24 x to the power of -5, or this is the same as 24 over x to the power of -5. I mean +5. Now see the order. Like first derivative, it was negative. First derivative, this is not derivative. First derivative, it was negative, then positive, then negative, then positive. Like For every odd derivative, 1, negative. At 3, negative. But for even, so that means I can say negative 1 the power of n. This will decide the sign. So which one contains negative 1 the power of n in the choice? The first one contains, the second one doesn't. I mean, A it contains, and C also it contains, and D also it contains. So the sign will be decided by negative 1 the power of n, because when n odd, it's negative, means negative 1 the power of odd will be, it's a negative. But negative 1 the power of even will be positive. So I can write negative 1 the power of n, the whole over, let's say. Now let us see the pattern of the denominator. For first derivative, it was 2. For second derivative, it was 3, the exponent. For third derivative, the exponent was 4, the denominator exponent. That means it is 1 ahead. First derivative 2, second it will come 3, so that I can say x the power of n plus 1. Again, which one contain? From these 3, which one contain this one? D. Obviously, the answer must be D. But to know the number, look at the numbers now. It was 1, then become 2, then 6, then 24. It's like growing high, like rapidly. So that this kind of growth, we can check it by factorial. This means 1 means 1 factorial, 2 means 2 factorial, 6 means 3 factorial, and 24 means 4 factorial. So we can say n factorial. So that one it contains at D. So the answer is going to be D. But even if you forget the factorial concept, we can check by the sign in the denominator exponent. The sign is negative 1, the power of n. How do we know? Like, how do we say it's n? Because for every odd, it's negative. For every even, it's positive. So negative 1 the power of n will decide the sign. Very good. And then go to the denominator exponent. The denominator is the x the power of what? N plus 1. For fourth derivative, it's 5. For third derivative, it's for the exponent. It's going in that pattern. So the answer will be D. Thank you for watching.